Find the vector which is perpendicular to the level curve of f, and which is direction decreasing. Now, to solve questions like this, you need to know the properties of the gradient. And the first thing that you have to know is that gradient is perpendicular to level curves. And in some cases, you don't have level curves, but you have level surfaces. See, if you have a 2-variable function like this, then you have level curves, but if you have a 3-variable function, you'll get level surfaces. So in that case, the gradient will be perpendicular to level surfaces. Second important thing is that the gradient of f is the direction f increases the fastest. Okay, and if you take the negative of the gradient, it will be the direction that decreases fastest. To understand what this 1 and 2 means, imagine that you have some level curves like that. At any point, there are 2 directions that are perpendicular to this level curves, right? So what the second one is saying is that if one direction, let's say this is gradient of f, then the other direction, negative gradient of f, will be the exact opposite, right? And the gradient of f direction is the fastest increasing direction, whereas negative gradient of f direction is the fastest decreasing direction. Okay, so that's what this number 2 is saying. And number 3, the norm of gradient of f is the maximal possible value of the directional derivative of f. Okay, these 3 are the important properties of the gradient that you have to know. And using this, we'll be able to solve part A. Okay, so let's read the question again. It's looking for perpendicular vector to the level curve. So we're definitely looking for gradient of f. But if you look at the second condition, we want it to be decreasing the most rapidly. So it's not looking for a gradient of f, it's looking for the negative gradient of f. So that's what we have to calculate. Let's calculate negative gradient of f. Remember, gradients are, you differentiate by x and then you differentiate by y. It's a partial with respect to x and partial with respect to y. And when you differentiate by x, you're treating y as a constant, so sine y is treated as a constant multiple, in which case when you differentiate, it doesn't change. You only differentiate this part, right? So differentiate e to the x gives you e to the x. Differentiating negative 2x gives you negative 2 sine of y. And then if you differentiate this by y, this time this x portion is considered as a constant multiple, so that doesn't change. And you only differentiate sine y, which will give you cosine y. Okay. And then because we need the vector at 4, 5, we should actually calculate this at 4, 5, which means x value is 4. So let's see. 4 is the x value and 5 is the y value. So let's plug them in. And let's bring the minus inside. So it'll be minus e to the x is 4. Sine of y is 5. Again, if you bring the minus inside, it should have minus e to the 4 minus 2 times 4 cosine of 5. Alright, so if you're doing this for the web work, I think the web work will accept this, but I think it's easier if you just use a calculator to further figure out what these numbers are. So here's a online calculator. The online calculator, the version I'm using is Desmos. That's pretty convenient. E to the 4th minus 2 times sine of 5. And that gives you this as the value. Let's paste it here. And for the second part, it's e to the 4th minus 2 times 4. 2 times 4, and instead of sine, you need cosine. Okay, and that gives you negative 46.42. And that's the vector. Yeah. This question also has the second part, and the second part is asking for a vector tangent to the surface. So the surface in question is z equals to this function, so it's like z equals to e to the x minus 2x sine of y. And then you can bring the z to the other side and rewrite this as 0 equals to e to the x minus 2x sine y minus z. So what we want to do is to define another function, this time a function of 3 variables, as this right side. You write e to the x minus 2x times sine of y minus z. The reason you want to do this is, first, notice that then fxyz equal to 0 is exactly this equation, right? Which is our surface S. Is the surface S. And this means S is a level curve, level surface of fxyz. This is wonderful because now we can use the property that gradient is perpendicular to level surfaces to get a perpendicular vector to the surface S. Now I have no idea what the surface S looks like, but let's say if this is a surface and this is the point 4, 5, something, there's this tangent plane that you can put, right? And the tangent plane would have a normal vector, and that normal vector will be normal to the surface as well. So this can be the gradient of f. So gradient of f would be perpendicular to the surface, which will also be perpendicular to this tangent plane. And any vector on this tangent plane would be perpendicular to our gradient of f. And that's a good property to use, because if I know what the gradient of f is, if I can calculate gradient of f, then that should be perpendicular to this tangent vector. I want v to be tangent vector. And if you have two perpendicular vectors, then you know that the dot product is 0, and that equation that you get should be enough to determine what a is. Okay, so that's the plan that I'm going to be using. Alright, so let's calculate gradient of f. And notice that if you do a partial with respect to x, because z is considered as a constant and constants differentiate to 0, you end up differentiating the exact same thing as before. It's the same derivative when we did part A. Again, when you differentiate by y, it's the same derivative. And the only difference is when you differentiate by z, x and y are considered as constants, so this is just a constant which differentiates to 0, and negative z differentiates to negative 1. And then when you evaluate this at 4, 5, which means x is 4 and y is 5, it will be e to the 4 minus 2 sine 5. These are the ones that I used the calculator to evaluate, right? So e to the 4 minus 2 times 4 cosine 5, and then negative 1. And that means that I can just use my previous values. The only difference is here we had the negative, so we will have to copy these without the negative values. So one would be this one. Okay. Okay. And the other one would be this one. Okay. And then you have the last component as negative 1. So that's my vector. And now all you have to do is to compute gradient of f dotted with v, in which case is what? See, dot product is component-wise multiplication, so 3 will get multiplied to this, which will give you 3 times 4.584238 plus, then you have 6 and 46, so 6 times 46.42083, and then plus a times negative 1. But that's negative a. That has to equal to 0. So if you bring the negative a to the other side, you end up saying that a must be 3 times 4.584238 plus 6 times 46.42083, which you can use the calculator for. So this one's the one with the plus. That's the 46 one, so that gets multiplied by 6, and then plus 3 times 4.582308. That gives you 292,719. So I'll just bring this down, and that's our final answer.